All right, so today we're going to be we're starting a new chapter, chapter 6. We're going to start off in section 6.2, which is the substitution method. For this chapter, you will be learning 3 methods. So the first one that I'm teaching you is the substitution, okay? So first, let's recap how many types of solutions there are. So there's 3 types of solutions. One solution, so when you solve, you will get one solution. And the graph, okay, that goes with one solution represents intersecting line. So when they intersect at one point, that's why it represents one solution. So one solution goes with intersecting lines. When you have many solutions, it represents 2 lines. One line on top of the other. So therefore, every single point represents a solution. So this also is called lines that coincide. It represents one on top of the other. So it has many solutions because every single point on this line is a solution. All right. And then lastly, the other solution that exists is no solution. That means the 2 lines will never intersect. So it doesn't have a solution. So basically when you have parallel lines, all right, you have no solution because these 2 lines will never intersect. So intersecting lines, okay, at one point represents one solution. 2 lines that form the same exact one represents many solutions because they're intersecting at every single point. And then parallel lines will represent no solution, all right? So now you will be given a problem that has 2 equations because it represents 2 lines, okay? And if I ask you solve this problem using the substitution method, your first step that you need to look at is, do I have a variable that's isolated? Okay, because you need to substitute one equation into the other. So for example, in this problem, you see how the first equation says y equals? That represents the y is by itself. So what does the y represent? Y is equal to 4x minus 6. So what does y represent? 4x minus 6. So that means that in the second equation where you see a y, you will substitute this expression into the y. So here, let me show you what your first step will look like. So 5x plus 3, what's y? 4x minus 6 equals -1. So as you can see, I substituted this equation into the second equation, all right? So I replace the y with what the y represents, 4x minus 6, all right? So now you're going to solve this equation for the x. So here you have a distributive property. So your first step is to distribute. Okay. Your next step is you need to combine like terms. Now you need to isolate the x. So what's the opposite of subtracting? Adding. So you get 17x equals 17. And then if you're solving for x, the opposite of multiplying is division. So you divide by 17 and you get x equals 1. Okay. So remember, you're solving for the point of intersection, and the point is x comma y. So I solve for x, okay, I have my x. Now I need to substitute this value into this equation in order to solve for y. So now I'm going to write y equals 4. What's your x? 1, what you solved. Okay. So you get y equals 4 minus 6, which gives you -2. So your y is equal to -2. So now you bring it all together. So the point of intersection, your solution, is a point. So my point is usually written as x comma y. So now I'm going to put these 2 information in as a point. So it's 1 comma -2. So this is your answer. Okay. So basically when you have a solution, you're going to be able to solve for the x or the y. And once you find one, you plug it into the other equation to find the other. And then you list your solution as a point. All right. So this represented one solution. Now let's do example 2. All right. Your first step is you look at do I have an equation that a variable is isolated? Which in this case I do. My first equation, they have y by itself. It says y equals, what's your y? 2x minus 4, right? So that tells me that I'm able to substitute this expression into my y in my second equation, all right? So I'm going to rewrite negative 6x plus 3. What's your y? 2x minus 4 equals negative 12, okay? So let's repeat it. Y equals 2x minus 4. What's your y? 2x minus 4. So I'm plugging this. I'm going to circle this, and I'm going to circle the y. So I'm substituting this into here. So therefore, I'm rewriting this equation, but I'm substituting this into here. So now I'm going to be able to solve for x. So I have to distribute first. Oops, sorry. I should get 6x. 3 times 2x is 6x. 3 times 4 is 12. Okay? So now, remember, you always have to combine like terms. So when I combine negative 6x plus 6x, I should get 0. It cancels out. That means I'm left with negative 12 equals negative 12. Now, tell me, see this, it won't have a one solution because all your x's canceled. But is this statement true? Yes, it is. This represents an identity. That tells you that it's basically going to be true for all numbers. Okay, so this represents infinitely many solution. And that's your answer. Or you could just write many solutions, is fine as well. Okay, so again, let me repeat that. Let's compare these two. Okay, this one represents a one solution because as I'm solving it, I'm left with an x. So I get a solution. So if I get a solution, that tells me that I have a point of intersection. So I got to plug in the x to solve for the y so I could have a point. Here, my my variables all canceled out, and I'm left with a true statement. So when I'm left with a true statement, that represents is going to be true for all, is an identity, represents many solution, okay? All right, so let's do one more. Okay, so here is the last problem, okay? Let's look at the two equations. Do I have an equation that has the variable by itself? Yes, I do, the second one. So I'm going to circle what it represents. It says y is equal to 2x minus 3. What is y? 2x minus 3. So I'm going to plug this into my y, all right? So I'm going to write 2x minus parentheses. What does the y represent? 2x minus 3 equals 8. Does everyone see the substitution? I rewrote this one. What's the y? Y is equal to 2x minus 3. So I replace this into the y, okay? And now I have a minus in front of the parentheses. So when I have a minus in front of a parentheses, this basically means you're going to distribute by negative 1. So basically there's a negative 1 here, so I got to distribute it, okay? So I get 2x minus 2x plus 3, okay? Because negative 1 times 2x, negative 2x. Negative 1 times negative 3 gives you a positive 3, all right? So now I'm going to combine like terms. What happens with the 2x? It says 2x minus 2x. That gives you 0. It cancels out. I'm going to be left with 3 equals 8. Now ask yourself, is this a true statement? Is 3 equal to 8? No, right? That's false. So this tells you is no solution. Okay? What does a no solution represent? Parallel lines. That tells you it will never intersect, so therefore it does not have a solution. So let's go recap. So one solution represents intersecting line, intersecting at a point. So example 1, okay, when I'm solving, if I get an x or a y equals, that tells me it has a solution. I have to find both values to write the solution as a point. When I substitute in and I'm left with just a true statement, because my variables canceled out. That represents an identity. So I'm going to have many solutions. And lastly, when I solve and I get a false statement that tells me I have no solution. So this is how an equation looks for all three types of solutions. All right. So this is what you're going to try today for classwork and for homework, your quizzes. Okay. I'm going to post this answer key as well, so you have it as a guide as well as the video. And if you have any questions, you can always email me.